All right, so now we're going to look at two examples of solving a logarithmic equation. And I will say that one of the main reasons logarithms are needed is really to solve exponential equations. So in a mathematical world, we sometimes ask, well, what real-world phenomenon can be modeled by this certain function that we're looking at? And there is a really good example of logarithms in our real-world context. And that is, if you think about the way that sound works and think about decibel levels, they're actually modeled by a logarithmic scale. But probably equally as important for logarithms is not just describing a real-world phenomenon, but actually using logarithms to solve exponentials. And so those are so helpful. But it's also helpful for us to look at logarithmic equations and to use what we had earlier was talking about how to be able to convert back and forth from logarithms to exponentials. And so let's look at we're going to look at two examples of a logarithmic equation and see how it's helpful to convert them to exponentials and then be able to solve from there. The first one is a little bit more straightforward, a little bit less going on in this problem. And so if you kind of see what this is going to look like, and it's actually similar to one that we looked at earlier. And so we have the log base 2 of x plus 1 equals 3. And remember that when we have a log equation like this, we typically have the variable, the x value, in the parentheses there. This one's fairly straightforward. We're going to think about just being able to convert this to the exponential form. And again, if you need to go back and look at where the values are in those equations, remember there was a b, there was an x, there was a y. Think about kind of where are they in those equations. Remember that the base of the logarithm right here, that 2, is going to be the same as the base in the exponential. And so what we're going to end up with says the base of 2 raised to the third power is equal to x plus 1. And so 2 to the third, hopefully you know, is 8. So 8 equals x plus 1. And so again, not too tough of a problem to be able to see that you should end up with something like x equals 7 by subtracting 1 from both sides. Okay, so this didn't use a lot of the rules, the bigger rules that we talked about. This is more just kind of understanding how to solve logarithmic equations in general. Let's take a look at kind of what does it look like to start to use some of those rules. And so if we have a problem like this where we have the log base 4 of x plus 1 plus the log base 4 of x minus 2 equals 1. Hopefully you see now that there are two different logarithms, and so that should kind of give you an idea that, oh, I might need to use one of those rules that I had. One of the bigger rules there. And remember, one of the big rules said that when you're adding two logarithms together, you can combine them together by multiplying what's inside. So you can convert this and transform this to be the log base 4 of what's going to be inside of the parentheses is going to be a combination of the x plus 1 and the x minus 2. You're going to multiply those together. I'm just going to write that out as x plus 1, x minus 2, and then we still have equals 1 on the right side. Now that you have just the one log by itself on the left side, now you can convert to that exponential form, and you could have 4 raised to the first power equals x plus 1 times x minus 2. And this actually is a quadratic equation. You could multiply on the right side, you could expand the two binomials that are there. You end up with something like x squared minus x minus 2. Okay, go ahead and check that. And equals 4. And so we end up with this quadratic, and hopefully you have some experience solving quadratic equations here. And what's helpful is to be able to think about kind of getting everything on one side. And so when we have x squared minus x minus 2, get everything to one side. So x squared minus x minus 6, I'm going to subtract 4 from both sides, and getting 0 on the other side. And if you can do this, then maybe the problem factors. And if the right side doesn't factor, then you could use the quadratic formula and be able to kind of find the values of x that are supposed to work in this thing. Fortunately, this problem does factor, and it factors as x minus 3 and x plus 2 equals 0. So you probably know then that you end up getting values like x equals 3 and x equals negative 2. Now, something to keep in mind is when we're talking about the logarithmic equation, do you remember what the graph looked like with this? I'll put it over here on the right side. Remember, the graph of the logarithmic function looks something like this, or at least it looked like that when you, kind of for the standard logarithmic function here. And so if you're thinking about kind of the domain of the function, we always want to know what's the domain of a function, because you might ask a question like, if I get values of 3 and -2, are those both okay? Are those both allowed? Well, the logarithmic function actually has a vertical asymptote right here on the y-axis, so you might notice that you're only allowed to really have values that are on the right side, only allowed to have values that are positive. And so when you talk about being able to plug values into the logarithm, you need to make sure that when you plug a value into the log, you're getting a positive value inside of the log. So what that means, all this to say, we actually need to go back and check our answer. Okay, our answer needs to work into the original problem. And so the original problem looked like the log base 4 of x plus 1 plus the log base 4 of x minus 2. And that was supposed to be equal to 1. And so the question is, if you plug in both of these values, 3 and -2, if you plug those in for x into the original equation, do you always get a positive value in the log function, or do you sometimes get negative, because we're not allowed to have a negative value inside of the log? So I hope it's pretty obvious that when you plug in x equals 3, you're going to be okay. So when you plug in x equals 3, you get the log base 4 of 3 plus 1. That's a positive number, so we're okay. And then plus the log base 4 of, it's going to end up being 3 minus 2. And that's a positive number, so we're okay there too. Okay. Now, where the difficulty might be is when we have a negative value of x, and so in this problem anyways. And so when we plug in a -2, we would have the log base 4 of -2 plus 1, and automatically right there you should say that's a problem, because the log base 4 of -2 plus 1, -2 plus 1 is -1, and so you can't have the log base 4 of -1. Remember, you're not allowed to plug in a -1 into your function. So that means that this value of x equals -2 is what we would call an extraneous solution. So sometimes we get these extraneous solutions, or what I would call fake answers. It's an answer, the value of -2 is an answer to the quadratic up above, but it's not an answer to the original problem, because the log function can't have a negative value inside of the log. So the only answer we would have here would be the value of x equals 3, not x equals -2. And sometimes we have these with logarithmic functions, so we want to be careful about what we find as our answers. We need to check those answers and make sure they work in the original problem.